Today we're going to talk about coordinate systems and how they plot. So, for instance, if I can get, let's see, I get a line here drawing, perfect. Draw like this, and draw like this. Okay, assume this is our Cartesian coordinates. We've got our x scale and our y scale. I'm just going to make it a little bit bigger. Our x and our y. This is how we go positive in the y. So it's here, it's in the plus, and here's how we go negative in the y. And on the left, we go negative this way, and on the right, we go positive this way. So we describe coordinates as like 2, 3, okay? That would mean it is 2 on the x. So we go over 2 on the x, 1, 2 on the x, and 3 in the y. 1, 2, 3 in the y. So that point, if I drag it over, and I use my other point to drag it up, this is where our point is right here. This would be 2, 3, okay? Let's put one in the next quadrant. I think this is the second quadrant below. So let's say down here, we would have the point 2, we would have the point 2, negative 3, okay? So the point 2, negative 3, it would go down 3 in the y-axis. That's what this negative 3 means. And it would go 2 to the right in the x-axis, just like before, like this. So this would be our point 2, negative 3. Let's check in the third quadrant. In the third quadrant, we would have negative 3, negative 2, let's say. So in this case, don't forget this is the x and this is the y. So we're going to go negative 3. I'm going to use red again. Negative 3 in the x, 1, 2, 3, there we go. And negative 2 in the y. So in the y, negative 1, 2. Bring this over, and our point ends up being right about here. Negative 3, negative 2. And in the fourth quadrant, we're going to have negative 3, positive 3 up here. So we go negative 3, so 1, 2, 3. And then positive 3, so the point is going to be right about here. That's our negative 3 and positive 3. So that kind of tells you like how we're going to plot things out on coordinate systems. The whole point of doing this is to be able to measure things in two-dimensional space. So let's imagine we have a Cartesian coordinate. I'll just draw like a fake one just for a second. And we want to see like what happens to a function. So a function might look something like this. That's our function that we have. So what we do to figure out how it works is we say, okay, if this is, f of x, which means a function, then I put a number in and I get a number out that looks something like this. So imagine it like basically like a black box, okay? You got this black box, f of x is the black box. We're going to put in numbers, we're going to get out numbers. And in this Cartesian coordinate that we have above here, let's just make some guesses. So if we put in a number for y, this is the y part out, right? Y equals f of x. So if we put a number for y like 0, okay, so let's say when y is 0, let's say here, it has two answers. When y is 0, x is negative 1, let's say, and when y is 0, x is plus 2. Those are our coordinates. When y is negative 1, then x is 0. Up here, we can check when y is like 3, then x is like 3. So this is all just ways to map what happens. A great example would be in your car. So in your car, you have a certain way you can accelerate before you shift gears, right? So the graph might look something like this. If y is the amount of like speed you get, let's say, you would start at 0. So there's gear 1, gear 2 kind of goes like this, gear 3 kind of goes like this, gear 4 goes like this. Oh, maybe it's going to correct it for me. Yeah. So what we would say then is, this would be where we have our first gear, our second gear, our third gear, and our fourth gear. And the thing we're doing, this f of x, this machine to see, what goes in gives us what come out, we end up with something like this. When x is 1, then y is 1. When x is 3, then y is 2. When x is 4, then y is 5, something like that. So that's how you plot coordinates on Cartesian planes. And you can describe these curves in equations. So let's do another equation that would describe this curve. So let's say we've got, just one of the classics. So here's our Cartesian coordinates again, and our graph looks kind of like, our graph looks kind of like this, okay? And this is an approximation of y equals x squared, okay? Let's break these out. So when y is 0, we're going to make a new chart down here and just show out the values first. So we got our y values and our x values. When y is 0, x is 0 because it's 0 squared, okay? When y is 1, x is 1 squared, which equals 1. When y is 2, x is 2 squared, which equals 4. When y is 3, it's 3 squared, which equals 9. So let's plot these points together. 0, 0, we've got that point right here, okay? The next one is 1, 1. So we go over 1, up 1. There's our next point. The next one's 2, 4. So go over 2, up 4. That's our next point. 3, up 9. Or sorry. When x is 3, y is 9. That's right. Just erase these to make it a little more clear. So when x is, I've got the equal sign over here. That's what's confusing me. There we go. So when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. There we go. So there's our 9 up here. Anyway, that shows you that piece. If you go negative on the axis, you've got the same situation happening. We'll just continue down here. So when x is negative 1 squared, y is 1. When x is negative 2 squared, y is 4. When x is negative 3 squared, y is 9. So go back to the plot, and of course that matches up here. So this is just an example of how to plot out these points on a Cartesian coordinate, and we're going to use that for lots of things in the future. Have a great day.